Welcome to this educational video on electrochemical processes and their relationship to natural cycles. Today, we're going to explore an interesting concept about sodium ions, electrochemical reactions, and how forces like gravity and evaporation are related through fundamental equations. First, let's understand this interesting time period that was mentioned, 16,848,000 seconds. This is approximately 195 days, which is close to half of a 13-month lunar year. Many natural cycles follow periodic patterns. For example, seasons change every quarter year, tides shift daily, and various atmospheric and oceanic cycles operate on different timescales. Now, let's talk about sodium ions and electrochemical reactions. Sodium, represented by the chemical symbol Na, is one of the most abundant elements on Earth's surface. When sodium loses an electron, it becomes a positively charged sodium ion, written as Na+. Electrochemical reactions involve the transfer of electrons between substances, resulting in chemical changes. These reactions are fundamental to many natural processes, from the water cycle to biological systems. Let's consider how sodium ions participate in global cycles. Sodium ions are abundant in Earth's oceans, which cover about 70% of our planet's surface. Through a process called sea spray aerosol production, tiny droplets of seawater are ejected into the atmosphere when waves break and bubbles burst. These droplets contain sodium ions, which can then be transported throughout the atmosphere by wind currents. Eventually, these ions return to Earth's surface through various deposition processes, such as rainfall. Now, let's discuss the forces involved in these processes. There are two primary forces at play: gravity, which pulls masses toward Earth, and forces that overcome gravity, such as those in evaporation. For gravity, we have Newton's law of gravitation, and inversely proportional to the square of the distance between them. For evaporation to occur, a water molecule must overcome this gravitational pull. This happens when the kinetic energy of the molecule becomes greater than the potential energy binding it to the surface. Let's compare the mathematical expressions for these forces. Both gravitational force and evaporation involve a balance of energies or forces. In gravity, we have an attractive force proportional to masses and inversely proportional to distance squared. For evaporation, we need the kinetic energy of molecules to exceed the binding energy. So while gravity attracts, evaporation represents a process that moves particles away from Earth's surface. In this sense, they can be seen as opposite processes, even though they're governed by different physical mechanisms. In conclusion, natural processes like the movement of sodium ions in electrochemical reactions are part of Earth's complex cycles. These processes involve forces that either pull components toward Earth or push them away. While gravity is a fundamental force causing attraction, other forces and energy transformations can result in particles moving away from Earth's surface, as seen in evaporation. These balanced processes maintain Earth's delicate equilibrium and are integral to many geological, atmospheric, and oceanic phenomena we observe.